Top 12 AI Code Review Agents for Engineering Velocity and Quality. Code review is essential for catching bugs and enforcing quality, but it can choke development velocity when done manually. In response, a new generation of AI-powered code review tools has emerged. These agents use static analysis rules and/or large language models, LLMs, to automatically inspect pull requests for bugs, security issues, style violations, and maintainability problems. By surfacing issues earlier and suggesting fixes, they promise to speed up merges and harden code quality. Below, we examine 12 leading AI code review agents, comparing their language coverage, static ML techniques, refactoring suggestions, and integration with IDEs/CI pipelines. We also survey performance benchmarks, bug catch rates, false positive noise, review cycle time, and consider data governance, repo access, LLM context limits, and policy as code configurability. Finally, we note gaps in the current market and suggest directions for future solutions. GitHub Copilot Code Review Overview. GitHub's Copilot, built on OpenAI GitHub Codex or GPT models, now includes a pull request review feature. When enabled on a PR, Copilot analyzes the diff and comments in line with suggestions or fixes. According to GitHub, GitHub Copilot reviews your pull requests and suggests ready-to-apply changes, so you get fast, actionable feedback on every commit. In practice, Copilot can flag simple bugs, suggest refactorings, and enforce style rules. Languages and frameworks. Copilot is language agnostic. Any code in the repo is fair game, though it works best for popular languages, JavaScript, TypeScript, Python, Go, etc. It leverages knowledge from its training/model rather than built-in static rules. Static plus ML fusion. Copilot relies purely on its LLM. It does not explicitly run traditional linters or static analyzers under the hood. However, its suggestions often echo common best practices, e.g., preferred naming conventions or missing error checks. Dynamic linting or formatting is typically done by separate tools. Refactoring suggestions. Copilot can offer concrete code changes on PR lines. In the UI, its review comments often include suggested changes that can be applied with one click. GitHub even allows a cloud agent mode where Copilot will auto-open a fix-up PR, implementing its suggestions. IDE-CI integration. Copilot Review is built into GitHub's web UI. Developers click Request a Review from Copilot in the PR Reviewers list, and Copilot responds within about 30 seconds. Comments act like a normal review, non-blocking. There's also Copilot support in VS Code and JetBrains IDEs to review code. This is effectively an in-GitHub solution. It does not run on-prem unless using GitHub Enterprise with data protection. Governance/context. Copilot uses the code in the PR and the repo context, up to its model context limit. You can embed custom instructions in a .github copilot instructions.md file to guide reviews, e.g. company standards. Note the 4,000 character limit on instructions. Access to code is through whatever repo permissions Copilot has, GitHub hosted. With a Copilot subscription, or free for org members if enabled, reviews are done in the cloud, which may raise IP privacy considerations for sensitive code. Amazon Code Guru Reviewer Overview. Amazon's Code Guru Reviewer is an ML-based code review service focused on Java and Python. It uses program analysis combined with machine learning models trained on millions of lines of Java and Python code to flag issues that humans often miss. It was designed to catch tricky bugs, resource leaks, concurrency problems, security flaws, etc., and suggest fixes. Code Guru does not focus on trivial issues. It won't flag syntax errors that your compiler would catch, but rather on deeper pattern matching findings. Languages/frameworks, Java and Python only. AWS may expand, but these are the current languages. Static ML fusion. Code Guru runs static analysis, for example using data flow analysis models, combined with learned ML patterns. It was originally trained on Amazon's own codebase, so it typically catches issues like redundant code, inefficient loops, or AWS API misuses. It also includes security detectors, SQL injection patterns, hard-coded credentials, etc. Refactoring suggestions. Code Guru comments include concrete recommendations. For instance, it might point out an unclosed JDBC connection or unused exception catch, then cite AWS documentation on how to fix it. It will even suggest replacing certain code with more efficient Java API calls. IDE-CI integration. CodeGuru Reviewer integrates with AWS Code Commit, GitHub, and Bitbucket Cloud. Once enabled on a repository, it runs on each pull request, or you can trigger it manually. It comments directly on the changed code. Setup is via AWS Console or CLI. There is no interactive IDE plugin, but you can view findings in the AWS Console. Performance metrics. AWS documentation claims CodeGuru reduces defects before prod, but published metrics are sparse. In practice, CodeGuru yields dozens of issues for a large codebase, but many are recommendations or low-priority warnings. False positives can be noticeable, so adoption guidelines emphasize reviewing its suggestions carefully. Governance/context. CodeGuru requires you to push code to AWS Git or connect GitHub and allow link. All analysis is done in AWS Cloud. IAM controls apply. CodeGuru cannot see code outside the scanned repo. There's no concept of on-prem execution. It fits companies comfortable with AWS and without strict bans on sending code to AWS. Deep Source AI Code Review Overview. Deep Source is a full-scale code review platform that blends static analyzers with AI assistance. Marketing calls it the AI Code Review Platform, offering high-signal issue detection across security, quality, complexity, and coverage. Deep Source's engine runs thousands of deterministic rules written in Python/Berlin, plus an AI review agent to vet pull requests. Languages frameworks, very broad. It supports languages like Go, Rust, Java, Scala, C, JavaScript, PHP, Python, Ruby, Shell, SQL, C++, Beta, Swift, Kotlin, etc. It also supports Docker files, Terraform, and more. In short, it covers most major web backend languages. Static Analysis Fusion. Deep Source's strength is its hybrid engine. It has nearly 5,000 built-in rules, bug patterns, style, complexity that automatically run on every commit or PR. In addition, it deploys an LLM-based agent to catch nuanced issues and to triage findings. The combination is meant to give high signal, low false positive issues, and structured feedback. Refactor suggestions. Deep Source can even auto-fix certain issues. It includes code transformers, formatters like Black, GoFMT, or code actions like remove unused in Java that can push formatting fixes or minor corrections as style transforms on PRs. Beyond that, the AI agent will sometimes suggest code clarify factoring points in comments. For example, it might note this long function can be broken up or consider using a list comprehension. IDE CI integration. Deep Source integrates with GitHub, GitLab, Bitbucket, and Azure DevOps. It runs on every PR. The Deep Source bot leaves comments on changed lines and a report card on code quality. They also have an IDE plugin and a CLI for local analysis, but the main use is as a cloud service scanning repos. Developers see issues inline in PRs. Performance. In large code bases, Deep Source often finds hundreds of issues, but insists on high precision. Their site boasts fewer false positives via AI. Independent benchmarks confirm it flags many issues, though some teams find it too noisy on style checks. It also tracks test coverage. Governance. Deep Source is SaaS. You connect your code repo by OAuth, so the Deep Source cloud reads all code. They claim enterprise security and on-prem or self-hosted runner options exist. Data governance requires reviewing their data retention policy. For context limits, Deep Source does not rely on an LLM prompt. It executes its static rules on the live code base. Snyk Code, SAST with AI, Overview. Snyk Code is the AI-powered SAST solution from Snyk, focusing on security and code hygiene. It uses an AI-based engine to reduce false positives and integrates early into development. Unlike some pure LLM tools, Snyk Code would be familiar to security teams. It complements Snyk's dependency scanning with code scanning. Languages frameworks. Broad support. Snyk Code covers most mainstream languages and frameworks. JavaScript, TypeScript, Java, .NET C, Python, Go, Ruby, PHP, etc., with frameworks like React, Rails, Django, Spring, etc. One source notes it supports all languages except Ruby for interprocedural analysis, and it works across major IDEs and CI/CD. Static Analysis Fusion. Under the hood, Snyk Code is a SaaS scanner, taint analysis, pattern matching, tuned by ML. According to docs, the AI-based engine results in fewer false positives for your developers. In practice, it flags security vulnerabilities, injections, XSS, etc., code quality issues, and enumerates fixes. Snyk's marketing emphasizes prioritized findings, showing risky bugs first. Refactor suggestions. SNCC code provides remediation advice, e.g. secure code snippets, library patch suggestions. Recently, they added autofix suggestions for some issues, especially common patterns, although full auto PR fixes are more limited than deep source. It can integrate with IntelliJ VS Code to highlight issues in real time. IDE CI integration. SNCC code can run in the SNCC web UI, GitHub GitLab PR checks, or via CLI and CI. It also has IDE plugins. When a PR is opened, SNCC can comment via GitHub status check or PR review with a summary of issues. Setup is straightforward via SNCC's integrations. Governance. SNCC processes code in the cloud, SNCC SaaS. Enterprise customers can use on-prem scanning or have options to avoid data storage. For context, SNCC code scans file by file, plus interfile flows, but large repos can be split. You control scanning by branches or PR scope and can exclude private patterns. SonarQube Cloud AI Code Verification Overview. SonarQube and Sonar Cloud is a longtime leader in automated code quality analysis. It has recently added AI features aimed at reviewing AI-generated or human code and pull requests. Sonar calls this AI code review, essentially combining its mature static analysis engine, SAST, with contextual AI hints. The product description. SonarQube delivers comprehensive automated code review capabilities, integrating static code analysis with real-time inspections into your pull request workflows. Languages, frameworks. Very broad, Sonar supports 35+ programming languages and frameworks, including Java, JavaScript, TypeScript, with frameworks like React, Angular, C, C++, Python, Go, PHP, Ruby, Swift, etc. It also analyzes infrastructure as code, Kubernetes, Terraform, in Sonar Cloud. Static ML Fusion. SonarQube's core is deterministic static analysis, finding bugs, security, code smells, test coverage. The AI review pitch appears to leverage its existing rule engine, plus maybe some machine learning on issues relevance. Sonar's site emphasizes context-aware feedback and AI-generated and assisted code review for things like design patterns or logic flaws. In practice, it is not purely LLM-based. Think of it as a very advanced linter that also highlights code that looks AI-generated, with suggestions. Refactor suggestions. Sonar flags maintainability issues, duplicated code, overly complex methods, etc., and recipes to fix them. Newer AI inspection claims likely surface more high-level smells. Sonar can enforce formatting and style, with autofix for languages like JavaScript via integrated Prettier. It won't write new code, but will suggest improvements line by line via comments. IDE CI integration. SonarQube runs on self-hosted or Sonar Cloud as SaaS. It integrates with CI/CD, Jenkins, GitHub Actions, etc. to scan code on every commit. For pull requests, Sonar can post review comments on changed code via the Developer Edition. There's also SonarLint for IDEs. The setup is often heavier, running the Sonar server, but widely used in enterprises. Governance. Sonar can be run on-prem, enterprise, or in cloud. Custom quality profiles let organizations encode policy as code, e.g. company-specific rules, coding standards. Enterprises love this for compliance. Sonar's model is local analysis. No code leaves your infrastructure unless you use Sonar Cloud. There are no LLM API calls here, so context limits are just what the static engine can process. Anthropic Claude Code Review Overview. Claude Code is Anthropic's developer-facing product based on Claude 3 Gemini. It offers an LLM-powered PR review feature targeted at teams. According to Anthropic's docs, a fleet of specialized agents examine the code changes in the context of your full code base, looking for logic errors, security vulnerabilities, broken edge cases, and subtle regressions. Like Cloudflare's custom solution, Claude uses multiple LLM sub-agents in parallel to improve precision. Languages frameworks. Language agnostic. Claude Code can review any languages in your repo. Its multi-agent approach means one agent might specialize in Python idioms, another in Java. In practice, supported languages include the usual suspects: JS, Python, Java, TS, C, etc. Though Anthropic doesn't publish an explicit list, it should handle mixed language repos. Static plus ML Fusion. The core is LLM. Claude Code takes your PR diff plus parts of the surrounding repository. Multiple LLM subclasses, agents, run in parallel on the diff and files and touches. After that, a review coordinator deduplicates and ranks the findings. There isn't a separate traditional static engine. The intelligence is entirely learned. However, organizations often complement it with sonar or language-specific linters as well. Refactor suggestions. Claude Code not only points out issues, but can also suggest code edits. In the UI, you get a mix of comment-style feedback and suggested changes buttons. Anthropic even offers a cloud agent mode, still in preview, that can implement suggestions by creating a follow-up PR. So it can automate small refactorings or fixes. IDE CI integration. Claude Code reviews are available on GitHub and soon GitLab via a GitHub app. After enabling Claude Code for an organization, reviews trigger on every push or can be manually requested with @ClaudeReview in comments. There's also a CLI and GitHub action if you prefer running it in your own CI. The findings appear as review comments tagged by severity. It's a managed service, Anthropic Cloud, rather than something you host, but they support GitHub Enterprise and on-prem CI usage. Governance context. Reviews are done in the cloud. Notably, Claude Code honors data settings. It does not retain code beyond analysis, no unmanaged fine-tuning. However, the code does leave your environment to Anthropic servers, unless you use the on-prem GitHub action. For context, Claude Code can ingest more than the usual LLM window by selectively feeding diff hunts and using the multi-agent coordinator to maintain context. Customization is supported via claude.md or review.md instructions in the repo. These let you encode style guides or project facts. Anthropic notes a caveat: it is not available for organizations with zero data retention enabled. This implies data privacy choices. Citations. We quote Anthropic's docs. Multiple agents analyze the diff and surrounding code in parallel. Each agent looks for a different class of issue. This highlights the multi-agent repo context strategy. CodeRabbit overview. CodeRabbit is an AI-powered code review agent emphasizing context-aware analysis of PRs. It aims to help teams review the flood of AI-generated code by understanding the entire code base. Its marketing slogan, cut code review time and bugs in half instantly, and reviews for AI-powered teams who move fast but don't break things. CodeRabbit positions itself as a leader in AI code review, claiming millions of repos and defects analyzed. Languages frameworks. According to CodeRabbit's FAQ, it is designed to work with all programming languages, including but not limited to Python, JavaScript, Java, C++, and Ruby. In practice, it covers any language in your repo. It also learns your team's patterns over time. Static ML Fusion. CodeRabbit's core is an LLM analysis. It mentions context-aware reviews that actually understand your codebase. It also runs real linters and security scanners for code quality and security, then uses 4 AI specialists to scrutinize the diff. So it is a hybrid, static analyzers plus LLM for semantics. Refactor suggestions. A standout feature is automated PR fixes. CodeRabbit can actually apply some improvements itself. For each PR, it can generate an AI summary of architectural impact, create file-by-file breakdown diagrams, and even open new PRs with suggested changes. In other words, you can ask CodeRabbit to implement suggestion, and it will draft a fix-up PR, similar to Copilot's Cloud Agent. This blurs the line between review and automated refactoring. IDE CI integration. CodeRabbit offers a GitHub GitLab app, 2-click install, as well as an IDE extension and a CLI. It integrates smoothly. After installing, PRs are automatically reviewed and commented on. The average time to first discussion is advertised under 5 minutes. No complex setup is needed beyond OAuth. Governance. CodeRabbit runs in the cloud, but it provides enterprise controls. You can opt out of data storage, so no code persists in their system. All code analysis is then live only. Its architecture implies it indexes your entire repo for context-aware results. Data privacy is a selling point. It claims compliance with security standards. Metrics. CodeRabbit cites its own impact. 50% faster reviews and 50% more bugs caught in one marketing graphic. While these numbers come from the vendor, they reflect typical promises. Real-world results likely vary, as Pandev's analysis shows a pure AI setup can miss context. CodeSpect overview. CodeSpect is an automated PR review tool targeting GitHub users. It advertises catch more bugs, review code faster, with specialized AI models. Unlike some all-purpose tools, CodeSpect uses a combination of pre-trained models tuned for certain languages and a general model for everything else. Its website even breaks down language coverage. For example, it has a specialized model for PHP Laravel and for JavaScript React Vue, plus a universal model that covers all languages. Languages frameworks. CodeSpec supports virtually any language. Out of the box, it lists specialized support for PHP, Laravel Blade, JSTS, React Vue, hooks. It also says all languages, general model for any codebase, with more on the way: Python, Go, Rust, Java, C. In short, it claims to handle any language via its general model. Static plus ML Fusion. This is a pure LLM approach, AI review bot. CodeSpec says its AI models are pre-trained on hundreds of senior engineer reviews. There's no mention of static analysis rules. It is essentially a contextual code reviewer powered by ML. It likely uses OpenAI or Claude under the hood with custom training. Refactor suggestions. In addition to comments, CodeSpec can suggest complete changes. It has a CLI and browser plugin to apply fixes. Its PR comments often come with fix suggestions that can be merged. So like Copilot, CodeRabbit, it goes beyond just flagging. IDE CI integration. As of now, CodeSpec integrates primarily with GitHub, app, and also offers a CLI IDE plugin. It was designed so installation takes seconds, 2-click install, after which it automatically reviews all PRs. It's focused on GitHub, so no built-in GitLab. Noise. CodeSpec boasts quick setup, 15 seconds, and asserts high accuracy, but independent reviews note that like all LLM checkers, it can be chatty. It claims to reduce noise by using high-signal models, but exact false positive rates are not published. Citing. CodeSpec lists a 50% more bugs caught stat and specialized language coverage, indicating its approach. Ellipsis overview. Ellipsis, formerly Terminus AI, is an AI code review and fix platform that is already installed in tens of thousands of GitHub repos. It promises AI code reviews and bug fixes on every commit of every pull request. It claims to catch logical errors, anti-patterns, security issues, spelling and grammar mistakes, documentation drift via LLM analysis, returning comments in minutes. Languages frameworks. Ellipsis advertises support for all languages. In practice, it handles anything from JavaScript and Python down to obscure DSLs, since it processes code as text with an LLM. It's especially noted for finding logic bugs. Static plus ML Fusion. Ellipsis is essentially LLM-driven. It doesn't explicitly run traditional linters. Everything comes from its AI inference. Each comment has a confidence score, and users can tune how many comments to emit by thresholding. Refactor suggestions. While Ellipsis primarily comments on issues, it also claims to do bug fixes. In practice, it can generate fixes and even create a follow-up PR if integrated. The UI has a fix-it prompt for each issue, somewhat like GitHub's implement suggestion. Integration. Ellipsis is available as a GitHub app and GitLab via a CI mode. After enabling, it reviews PRs automatically, typically in under 2 minutes. Review comments appear via GitHub's UI. It also has chat integration, Slack, to notify about issues. Scale. Ellipsis emphasizes its scale, installed in 67K plus repositories. Many open-source projects use it. It requires minimal setup. Just install the app. Governance. As a cloud service, Ellipsis does process your code remotely. They state that analysis happens on the fly, and you can adjust scope. There's no on-prem version. Code is sent to their API. Citing. Their docs highlight the 2 to 3 minute review latency and LLM bug checking. Senin overview. Senin is an enterprise-grade AI code review platform geared for large, complex projects. Its tagline, AI code reviews for complex projects. Senin's pitch is that it can handle massive repos and find subtle issues beyond traditional linters. It advertises 20 parallel agents, each one investigates a specific concern in the diff, similar to Cloudflare's multi-agent idea. Languages frameworks. Senin supports common enterprise languages, Java, C, Python, JS, etc. They don't list specifics publicly, but their UI icons include GitHub, GitLab, Bitbucket, and languages typical of complex projects. Static plus ML Fusion. Like Claude Code, Senin uses multiple LLM agents focused on different aspects: security, performance, documentation, stale references, etc. It likely also runs linter static checks as part of its pipeline. The goal is missed requirements and architectural drift detection, figuring out if the code meets spec. Refactor suggestions. Senin not only flags issues, but offers actionable feedback via comments and can file automated PRs with fixes. It also tracks discussions acceptance, On their site they say 76% of suggestions are accepted by developers. Integration. Senin supports GitHub, GitLab, Bitbucket apps. Once connected, it reviews PRs. Some claim 1 to 5 minutes to first comment. It also has Slack email notifications. Because Senin is enterprise-focused, it accommodates SSO and corporate security. Performance stats. Senin advertises saving 4 to 9 hours per developer per week and less than 5 minutes to first discussion, with 30% faster shipping. These numbers come from their user surveys. Governance. Senin is cloud-based and claims enterprise security. It uses company-specific rules. They mention deep knowledge of your business rules and architecture. They emphasize configurability. You can train it on your documentation and standards. They also stress it only flags real problems. Their marketing bars low volume of findings to avoid noise. Citing on Senin's site, 20 parallel agents. Each investigates a specific concern. And metrics like 30% faster shipping and 76% discussions accepted. Revin overview. Revin bills itself as an AI-driven code review and tech debt management platform. It promises to automatically analyze code for security, tech debt, and quality issues, and even deliver fixes as PRs. The slogan, "Your code, automatically reviewed." Essentially, it tightens the feedback loop by creating pull requests with the suggested fixes. Languages frameworks. Revin covers all common languages. They explicitly list PHP, JavaScript, TypeScript, Python, Java, C, Go, Ruby, Rust, and more. They note that underlying AI, Claude, is language agnostic. This is a broad list and likely covers anything a typical web enterprise stack uses. Static ML Fusion. Revin combines static rules, they call them 41 analysis rules, with LLM analysis. Their docs mention using Claude's AI analysis as part of their pipeline. We can infer they run linters and vulnerability scanners, e.g. for SAST and secret detection, and send code to the AI for deeper insights. Refactor suggestions. Revin's standout feature is auto-fixing. For every issue found, Revin can open a follow-up PR with a suggested code change. This turns code review from comment only to edit and fix. For example, if it sees a misspelled variable or a simple logic bug, it will push a fix PR. This is noted in their marketing and delivers fix suggestions as pull requests. Integration. Revin supports GitHub, GitLab, and Bitbucket. It shows logos on its site. You install an app or add a bot user, and it reviews PRs automatically. It boasts a quick setup, x 5 minutes, and then runs continuously. Users interact with it much like a human reviewer, with comments, suggestions, and PRs. Governance data. Crucially, Revin runs exclusively on EU servers, Hetzner in Germany, and is 100% GDPR compliant. This makes it attractive for organizations concerned about data residency. Code does leave customer premises to Hetzner, but they emphasize no cross-border transfers. They also allow opting out of data retention. Citing from Revin's FAQ, Revin analyzes code in all common languages: PHP, JavaScript, TypeScript, Python, Java, C, Go, Ruby, Rust, and more. Claude's AI analysis understands context regardless of the language. Also note the hosted location and GDPR claim in the header. Scrubby overview. Scrubby is an AI-powered code review platform currently in beta, geared toward teams looking for code-based intelligence along with PR review. Its tagline, "Smarter agents, fewer bugs, and less AI slop." It combines automated review with mapping the architecture of your code. Languages/frameworks. Scrubby supports a concise list: JavaScript, TypeScript, Python, Ruby, Go, and Java, with special intelligence for frameworks like React, Next.js, Rails, Django, etc. This covers many modern full-stack apps, though it does not yet list C, PHP, etc. Static ML Fusion. Scrubby's approach is multifaceted. It runs standard code analysis and security checks, but overlays that with LLM context. It boasts features like pattern extraction and code change detection, automatically finding related parts of the codebase. The idea is not only to review the diff, but to understand how code fits in the larger architecture. For example, a change in a service might trigger an architectural review by AI. Details are sparse since it's closed beta. Review automation. For PRs, Scrubby writes comments on bugs or style issues, an AI code review, but it also offers convention enforcement, applying company style automatically, and onboarding acceleration, helping new devs understand the repo. The agent context feature suggests it can feed project-specific docs to the AI. Integration. Currently, Scrubby is offered as a hosted beta. It appears to integrate with GitHub for PR scanning. It also has an agent running agents that can connect to your repo. Specific IDE support isn't advertised yet. Governance. Since Scrubby is still in beta, full details are limited. It is cloud-hosted, no on-prem solution yet. It advertises token optimization to fit LLM context, implying it smartly structures prompts to avoid hitting limits. Citing. From Scrubby's FAQ, Scrubby supports JavaScript, TypeScript, Python, Ruby, Go, and Java, with framework-specific intelligence for React, Next.js, Rails, Django, and more. Also note its emphasis on code-based mapping and pattern learning from their features list. Key metrics and benchmarks. While vendors tout efficiency gains, independent data reveal the true impact of AI review. A large survey by Pandev Metrics, 100 teams, 24 KPRs in 2025-26, found that a strict hybrid model, LLM plus mandatory human sign-off, halved review time versus baseline. In contrast, an AI-only model, auto-approve if no issues, led to more bugs in production. Defects escaping jumped from 2.8% to 4.1%, etc. In other words, AI review can boost speed, but may miss context unless humans stay in the loop. Pragmatic KPIs from real users are mixed. Atlassian reports that its internal AI reviewer, RoverDev, cut their PR cycle time by about 45% over one day, dramatically speeding merges. They also saw new engineers merging first PRs 5 days faster with AI assistance. On the other hand, many teams face false positive noise. Naive LLM prompts can flood PRs with frivolous comments. Cloudflare engineers found that a single LLM reviewing a diff would spit out 10 or more findings per review of dubious quality. They mitigated this by filtering generated code noise and biasing models for signal over noise, resulting in only about 1.2 substantive findings per review on average. Overall, the promise is clear. Properly tuned AI review can slash review queues and let senior engineers focus on critical issues. But in practice, success hinges on signal-to-noise ratio and integration. Each tool reports varying discussions accepted rates. For example, Senin claims about 76% acceptance, implying about 24% noise. End-to-end studies emphasize measuring both time saved and bug escape rates together. Tools can speed up reviews, but only a hybrid human plus AI approach reliably improves quality. Data governance and policy as code. Modern AI agents raise important governance questions. Code access. All above tools require read access to your repository. Some embed into hosted CI. Copilot, CodeGuru, DeepSource, Smeek, Ellipsis, Revin all read your cloud repo. Others, Kaizen, Chorus, some OSS tools, let you run locally. Tools handling proprietary code must be vetted carefully. For example, Revin explicitly runs only in EU data centers, Hetzner, Germany, and advertises GDPR compliance, whereas Copilot and Claude send code to US-based LLM servers. If on-prem reviews are needed, options are limited. Sonar can self-host, many startups are SaaS only. Model context limits. A persistent issue is LLM input size. No tool can send an entire project to an LLM in one go. Vendors use strategies like diff filtering, dropping tool-generated or irrelevant noise, as Cloudflare did, and multi-agent orchestration. For example, Copilot reviews only the PR diff, plus maybe open files, and ignores huge libraries. Claude Code and Senin spawn multiple smaller LLM sessions, focusing on slices of the code. Kaizen, the CLI tool, explicitly orchestrates 4 AI specialists in parallel on semantically different checks. None fully escape the context window limitation. Large changes may need manual partitioning. Policy as code. A mature AI review strategy requires embedding company standards. Some tools support custom rule libraries. SonarQube's quality profiles or DeepSource's custom analyzers let you encode style and architecture rules. Others use instructions. Copilot and Claude support repository-specific instructions files that guide the AI's judgments. Atlassian's experience highlights ensuring PRs meet JIRA acceptance criteria by connecting PRs to issue definitions, essentially policy-defined in issue fields. The Cloudflare case notes using an engineering codex plugin to enforce internal norms. In short, vendors vary widely. Static-oriented platforms excel at codifying rules, while LLM-based agents are beginning to offer optional instruction files. There's a gap here. Few solutions fully combine high-fidelity policy as code, like custom OPA policies or DSLs, with LLM review logic. Conclusion and opportunities. In summary, AI code review agents range from static analysis natives, deep source, Sonar Sneak, to LLM-first reviewers, Copilot, Claude, CodeRabbit, Elixir. Established tools like DeepSource and Sonar are robust and cover many languages, but may feel traditional in focus. LLM-based agents offer more open-ended feedback, architecture suggestions, English explanations, but can be noisier and are still refining support for diverse codebases. Notably, no one tool truly covers all languages and places. Even Copilot, while broadly capable, is limited by GitHub's ecosystem. CodeGuru only does Java, Python. Some high-profile gaps in current offerings: context awareness, large system logic, multi-file context remains hard. Claude and Senin's multi-agent tricks are promising, but many tools still treat PRs in isolation. A next-generation solution could deeply integrate full code understanding, mapping calls across repos, using build information, etc., so reviews truly consider system impact. On-prem/hosted use. Companies with strict IP rules often can't send code to external LLMs. While tools like Sonar or local CLI KaiZen exist, a self-hosted multi-LLM engine for code review is lacking. Entrepreneurs could build a framework where teams run their own LLMs behind a PR bot. Unified static plus AI. Some platforms mix static and AI, but often they feel tack-ons. There is room for a seamless platform that runs sophisticated linters, SAST, and LLM agents in concert. For example, a tool could flag a null pointer via static analysis, then use an LLM to suggest an idiomatic fix in one step. Policy integration. The ability to encode compliance or architecture rules, policy as code, into the review process is still nascent. A tool that lets you express organizational policies, security rules, style guides, or business logic invariants in a machine-readable form and checks them via AI would fill a need. Atlassian's Rovo hints at this by linking to Jira items, but a commercial product could make that easier to adopt. In no case are these agents a complete substitute for human reviewers. Current data shows human plus AI in tandem is safest. Where AI shines is offloading the mundane checks and catching low-hanging bugs early, thus shift-lefting review effort. Teams interested in adopting these tools should plan to calibrate them, tune rules, feedback preference, monitor defect escape, and keep the feedback loop open. In summary, AI code review tools have evolved rapidly and now cover a wide spectrum of code bases. GitHub Copilot, AWS CodeGuru, DeepSource, Sneak, SonarQube, Anthropic's Claude, CodeRabbit, CodeSpect, Elixir, Senin, Revin, and Scrubby, among others, each bring unique strengths, but no single agent is perfect. A best-of-both worlds future solution might combine multi-language static analysis, LLM-driven review with full code-based context, seamless IDE CI integration, and strong data governance, on-prem options, all while allowing teams to program their own standards. Such an integrated agent, lowering noise and bias while scaling with any project, would significantly boost engineering velocity and code quality. It remains an open opportunity for innovators to build the next generation of AI code reviewers. All links to sources are available in the text version of this article. You can find the full article at aiagentstore.ai/agentic AI and workflow automation. Thanks for listening, and thanks for rating the show. Visit aiagentstore.ai to discover agents, tools, and setup files that help you work faster and automate more. You'll also find Claw Earn, our job marketplace where AI agents and humans can both work and create tasks, plus marketing solutions for AI product founders. Explore it all at aiagentstore.ai.